central forces. What are central forces? The forces which act along the line joining the particle to the center of the force. वो फोर्सेस जो सेंटर के अलॉन्ग लगती हैं, वो फोर्सेस जिनका मैग्नीट्यूड सिर्फ और सिर्फ डिस्टेंस पे डिपेंड करता है बिटवीन द पार्टिकल टू द सेंटर ऑफ फोर्स, एंड दैट इज द सेंट्रल फोर्स कैन बी रिटन एज F वेक्टर that is equal to Fr and R. Fr is the magnitude, that is the magnitude of the force is only the function of which is only the function of the distance of the particle from the center of the force, and this R cap is the unit vector which tells us about the direction, किस direction में force लग रही है, and what is the direction that is always at along the line joining the particle to the center of the force. तो ये थी central force की definition. Now in our nature the gravitational forces, the electrostatic forces are nothing but the example of the central forces. Now why are we giving importance to the central forces? They must hold some properties that are very much advantageous for us, है ना? तो वो क्या है? What are those properties of the central forces? The properties of the central forces are very important, and the first property is that the central force are conservative in nature. The central forces are conservative in nature. And what do you mean by the conservative forces? The conservative forces means that they do not depend upon the path. The conservative forces are path independent. That is, the work done by the conservative forces are path independent. The work done only depends upon the initial and the final position. And you must also know that the curl of the conservative forces, whenever you take the curl of the conservative forces, it always comes out to be 0. So whenever you need to check the force is conservative or not, so you just take out its curl. If it is coming to be 0, the forces is conservative. And the conservative forces can be written as the negative gradient of their corresponding scalar potential. The conservative forces can be written as the negative gradient of the scalar potential. That is, we can write the conservative force as the negative gradient of the scalar potential. And the central forces का एक जो मेन पॉइंट है, दैट इज अगर कोई भी बॉडी आपकी सेंट्रल फोर्स के इन्फ्लुएंस में है, whenever a body moves under the central force, so the angular momentum of that body always remains conserved. उस बॉडी का angular momentum हमेशा conserved ही रहता है. That is, angular momentum is mvr, mr square theta dot. So mr square theta dot is always conserved if the body is moving under the action of the central force. So this is also main property. And you should also know that what is torque? Torque is the vector product of the r, that is the position vector, and the force, that is r cross f. Now gravitational force is a central force. So I can put the gravitational force here. Now you can see r cap, r cap. R cap and r cap are the parallel vectors, right? Gravitational force is a central force. It acts along the line joining the center of force, and here is the position vector along that. So पैरेलल वेक्टर्स का क्रॉस प्रोडक्ट क्या होता है? 0 होता है. पैरेलल वेक्टर्स का क्रॉस प्रोडक्ट 0 होता है, तो टॉर्क 0 आ गया. एंड टॉर्क इज नथिंग बट द रेट ऑफ चेंज ऑफ एंगुलर मोमेंटम विद रिस्पेक्ट टू द टाइम. So torque is nothing but the rate of change of angular momentum with respect to time, and it is coming to be constant. That is, torque is coming to be 0. So that means any quantity in which the quantity has its derivative 0. So that means the quantity is nothing but the constant quantity. So that means it is the proof that when the body moves under the action of central force, so that is the constant. Angular momentum is the constant for that body. And one more important point, whenever the body moves under the action of central force, so its motion is always confined to the plane. It means if this is the L vector here, this is the mv vector of the body, so the body motion is always confined in this plane, because you know that L vector is nothing but a constant vector whenever you're talking about the central force, and L is nothing but r cross mv. So if L is a constant vector, and that means r and v का cross product will give you a vector. Cross product of two perpendicular vectors gives a vector that is perpendicular to both the vectors. So L vector is perpendicular to both V and R. So whenever a body moves under the action of a central force, so its motion is always confined in a plane. One more important point to be noticed is that अगर हम हमारी problems को easy बनाना चाहते हैं, so we always do one thing, that is to reduce a two body problem into a one body problem. तो मान लीजिए आपके दो पार्टिकल्स m1 एंड m2 हैं जो मूव कर रहे थे अंडर द इन्फ्लुएंस ऑफ द ग्रेविटेशनल फोर्सेस. नाउ आई वांट कि मैं दो बॉडीज को लेने की बजाय एक अपनी प्रॉब्लम को वन बॉडी में रिड्यूस कर दूं. सो व्हाट यू डू इज दैट यू इंट्रोड्यूस द कंसेप्ट ऑफ द रिड्यूस्ड मास. यू इंट्रोड्यूस द कंसेप्ट ऑफ द reduced mass, and reduced mass is nothing but the 1 over m1 plus 1 over m2. You always need to remember the formula for reduced mass is m1 m2 over m1 plus m2. And important point to be remember about the reduced mass is that कि आपका जब भी हम दो बॉडीज का रिड्यूस मास लेते हैं और उनमें से अगर आपकी कोई बॉडी बहुत ज्यादा हैवी है दूसरी बॉडी से, दैट इज टू बॉडीज m1 एंड m2 इन विच m1 इज हेवियर एंड द m2 इज वेरी वेरी लाइटर देन m2, तो रिड्यूस मास आपका हमेशा लाइटर बॉडी के पास ही लाई करेगा. For example, here I have taken the case of electron and proton. Proton is near about 1836 times heavier than electron. So mu is equal to m1 into m2, m1 plus m2. You solve it and you get that जो आपका mu है, reduced mass है, that will be approximately equal to the that of the electron का mass. That is, reduced mass is always approximately equal to the mass of the lighter body. So this is also the conceptual question that can come from this topic.